Would you dare drink carpet cleaner, washing machine water, or even your own urine? Sounds disgusting, right? But the truth is, millions of people in the world's wealthiest countries are drinking toilet water every day without knowing it. This isn't a joke. From Singapore to major US states, the black, foul-smelling wastewater from millions of households' toilets is being pumped back, filtered through ultrafiltration membranes, and subjected to high-intensity UV rays. The result is ultra-pure water, hundreds of times cleaner than regular tap water. Is this technology truly safe, or are we simply inviting disease into our bodies? Watch this entire video to find out where the water you'll be drinking in the future is actually coming from. In fact, water recycling technology wasn't developed because people wanted to create a new water source, but because many places are gradually depleting their existing water sources. In many large cities like Mexico City or Jakarta, excessive groundwater extraction over decades has caused the land to subside annually. Meanwhile, climate change and prolonged droughts are making it increasingly difficult for rivers and reservoirs to meet the needs of a constantly growing population. That's why many countries are beginning to view wastewater as a resource rather than a type of waste to be disposed of. Singapore is a prime example. Due to its almost insufficient natural freshwater resources, the country has invested heavily in recycling technology to ensure water security. In the US, the water recycling system in Orange County currently processes nearly 500 million liters of water per day, replenishing groundwater aquifers and providing a stable water supply for hundreds of thousands of people. However, this technology also has limitations. Not all types of wastewater can be treated to become drinking water. In particular, industrial wastewater, containing many toxic chemicals and heavy metals, often needs to be treated separately before it can enter advanced filtration processes. Every water recycling journey begins with a source most of us want to avoid: wastewater. Each time we flush the toilet, shower, wash clothes, or wash dishes, the water doesn't disappear. It begins its journey to a treatment plant. Not only that, the system also receives wastewater from hospitals, schools, restaurants, hotels, and numerous manufacturing facilities. All of this mixes into a massive flow, carrying all sorts of impurities, from toilet paper, hair, food scraps, and countless dissolved organic substances. The scale of this water is far greater than many imagine. A single large-scale wastewater treatment plant can receive tens to hundreds of millions of gallons of water per day. This flow continues 24 hours a day without interruption. However, despite appearing as a worthless mixture, engineers view it as a raw material for creating the clean water we drink every day. Upon arriving at the plant, wastewater cannot go directly to the sophisticated treatment stages. The first step is to remove the largest impurities to protect the entire process. The water passes through steel screens, where toilet paper, plastic bags, rags, twigs, and various other debris are retained. In large-scale plants, this system can collect over 20 tons of waste per day, preventing it from clogging pipes or damaging pumps. After removing coarse debris, the water continues into a sand separation tank. Here, the flow rate is reduced just enough for sand, gravel, glass fragments, and heavy inorganic particles to settle to the bottom, while the water continues to move forward. The final stage of pretreatment is oil and grease separation. Due to their lighter weight compared to water, oil and grease float to the surface and are collected by automatic scrapers. After these first 3 steps, the water has had most of the large impurities removed and is ready to enter the more complex biological treatment stage. After the large impurities have been removed, the wastewater still contains countless small suspended organic particles that the trash screens cannot retain. To treat them, the water is directed into huge primary settling tanks and held for about 2 hours. During this time, the heavier organic particles will slowly sink to the bottom, forming a thick layer of sludge called primary sludge. Through this natural settling process alone, the plant can remove about 50% of the suspended solids and 25% of the organic matter in the wastewater. The sludge at the bottom is then pumped to a separate line for further processing, while the water above, although clearer, still contains billions of bacteria and dissolved organic matter. After most of the solids have been removed, the wastewater still contains a large amount of dissolved organic matter invisible to the naked eye. To treat this, the water is fed into aeration tanks, where billions of beneficial microorganisms are waiting. Air is continuously pumped to the bottom of the tank to provide oxygen, creating conditions for the microorganisms to thrive. They use the organic matter in the wastewater as a food source, breaking it down into water, carbon dioxide, and new biomass. In just a few hours, this process can remove 85 to 95% of the remaining organic matter in the water. As the food source gradually runs out, the microorganisms clump together into large sludge flocks, which easily settle in the next tank. At this point, the water is much clearer, but it still contains bacteria, viruses, heavy metals, and tiny dissolved substances. That's why it needs to go through the membrane filtration and reverse osmosis stages. First, the water is passed through ultrafine membranes with pores of only about 0.1 micron, small enough to retain most bacteria, parasites, and remaining tiny particles. Then comes the most important step, reverse osmosis. Here, water is forced under pressure up to 250 psi through a special semi-permeable membrane. This membrane allows almost only water molecules to pass through, while salts, heavy metals, viruses, microplastics, drug residues, and many other dissolved pollutants are retained. Although the water has achieved a very high level of purity after the RO system, it is not yet ready for immediate use. First, the water undergoes a final disinfection using ultraviolet light, ozone, or the addition of a very small amount of chlorine to completely eliminate any remaining microorganisms and ensure the water remains safe during distribution. Next, the system adds a small amount of minerals such as calcium and magnesium and adjusts the pH to give the water a more natural and stable taste. After completing these steps, the water is tested against several rigorous standards before officially becoming a source of clean water for human consumption. A series of automated sensors continuously monitor parameters such as turbidity, pH, mineral content, disinfectant residue, and total dissolved organic matter. Simultaneously, water samples are periodically taken for laboratory analysis to detect bacteria, viruses, heavy metals, and hundreds of other indicators according to drinking water standards. Only when all results meet the requirements is the water allowed to leave the plant for distribution or bottling. So now, would you dare to drink it? If the answer is no, you might be surprised to learn that millions of people have been drinking this water for a long time without knowing it. After passing hundreds of rigorous tests, what was once wastewater now fully meets the standards for drinking water. And to become a complete product, before it can hold even a single drop of water, the bottle itself must be created. Instead of shipping bulky empty bottles, most factories import compact PET preforms, resembling test tubes with pre-shaped necks. These preforms then pass through a heating system at around 250 degrees Fahrenheit, softening the plastic and making it pliable enough for molding. Immediately afterward, each preform is placed into a mold, where a pull rod stretches it vertically, while compressed air at pressures up to 580 pounds per square inch simultaneously blows the preform against the mold walls. In just seconds, a small plastic preform is transformed into a complete bottle with precise details, from the body and bottom to the reinforcing ribs. The newly formed bottles then move directly to the automated filling line. First, they are cleaned with sterile air or washed with treated water to remove any remaining dirt. Then, the water is filled into individual bottles with precisely controlled volumes and immediately sealed to prevent recontamination from the external environment. Next, an automated system labels the bottles, printing the production date and batch code, before high-speed cameras inspect each bottle for insufficient water levels, loosely capped caps, or any packaging defects. Only bottles that pass all the final checks are packed into cartons, placed on pallets, and shipped to distribution centers. Just days later, they may appear on supermarket shelves or in your refrigerator, even though just hours before, they were wastewater that most people thought would never be drinkable. From a murky, seemingly disposable wastewater stream, through a series of processes ranging from biological treatment, membrane filtration, reverse osmosis, to disinfection and rigorous testing, it has become a source of water safe enough for daily human consumption. Amazingly, the biggest hurdle for this technology is no longer its ability to purify water, but rather changing how we perceive it. What about you? If you knew a bottle of water that was once wastewater had now passed all safety standards, would you be willing to drink it? Leave your opinion in the comments. And don't forget to like, subscribe, and turn on notifications to stay updated on our next exciting technological journeys.